Hello guys, I'm going to start solving a problem for influence lines, and there's going to be several parts in that problem, so let's get to work. Okay, first let's start seeing what is the structure that we are going to be solving today. It's a simple beam, and the method that I'm going to use for this is the first approach that I talk about in the introductory lecture. And I say that is, I call it brute force because I think it's the most appropriate name for that. This is a very simple beam, 4 meters every one of these length here, and the problem is going to have several parts. So I'm going to start working in the part A. The part A is going to be reactions. Influence line. Draw the influence line for the reactions at support A and at support B, meaning AY and BY, these two reactions here. That's what we have to do. And if you remember, with this is AY and this is BY. If you remember when we were discussing influence lines and the difference between influence lines and regular shear moment diagrams, is what happened is in the real shear moment diagrams, axial shear moment diagrams, the loads are fixed. The loads don't move because this is mainly for dead loads, if you don't consider them moving, of course, dead loads. And then you move through the beam to calculate the values at different points. In this case, it's not like that. In this case, you're gonna have a load, and the load is gonna be at one instance it's gonna be here, and the other instance is gonna be here. Let me see if I can. What I'm trying to tell you really quick, an error. Well, I don't have an error, but I have something like this. Look at that. So basically, what is gonna happen here in this beam, that you're gonna have a moving load like that, and the moving load is gonna come like that's it. It's gonna change from one, and credits go to this award for that song. That goes from here to there, and it's gonna be moving, and we don't know where it's gonna be moving. So what we are going to do in the brute force approach is I'm going to assume that load is at different points. And the first, of course, most obvious part would be when the load is at that point. Usually you indicate the position of the load measuring a distance x from here to there, x. So for that particular point, you can say when x is 0, because x at that point is 0. And you can do that in the same way that you do any statics analysis, and you say summation of moments at A equals 0. And if you do moment at A equals 0, what do you get from here? You say that BY is, there's nothing else, right? BY times this distance is 0, so BY is 0. And if I do summation of forces in Y equals 0, then you're gonna have AY minus 1 plus BY equals 0, but BY is 0, so AY equals 1. It's so easy. That's what we have, and we already have the first value for influence line. I'm going to be building a table here to try to keep it organized. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, including the heading. And this is gonna be x. This is gonna be the reaction at A, the reaction at Y. So this is gonna be x when x equals 0, AY is 1, and BY is 0. That's what we got. First point done. You don't have to do this every single time. I'm doing that because this is the first problem that I'm asking you to do. Because this is obvious. If the load is completely on top of the support, that is the support that is absorbing that load, that unit load, and the rest of the other supports are not taking any load because the load is completely on top of that support, and you don't have to do this analysis. Now the second part will be when x, I'm gonna move that load from here, and then you remember tan ta tan ta tan ta tan ta tan ta tan ta tan. So the load is moving. Now the load is here in the second position, and by here I mean when the load is at 4, x equals, I'm sorry, x equals 4. When x equals 4, I do the same thing. Summation of moments at A equals 0. If I do that, then you have 1. Remember that value of that load is 1. 1 times 4, negative 4 times 1, or 1 times 4, plus 8 times By equals 0. And then you can solve for By, and By for this it will be 0.5. What units? Quick, tell me. Units for this. What are the units for Ay and By? None, because this is dimensionless. We are doing unit influence lines, and we don't put any unit when you draw the influence lines. The units will come afterwards, and I will explain you how. And then we do summation of forces in Y equals 0 for the second step. So you have Ay minus 1 plus By equals 0, and then you can solve for By. By is 0.5. If you put that here, so for the second, I'm sorry, Ay for the second part, if you put that By here, negative 1 plus 0.5 is negative 0.5, pass it to the other side, 0.5. So you have this part. For x equals 4, x is in meters. That could be, you have a unit there, but we don't have any unit for this. The reaction in Ay, when a unit dimensionless load is moving from left to right, and x equals 4, the value will be 0.5, and for b will be 0.5 also. Now move the load, take it out, now put it here. You want me to sing the song again? There you go, load is there. We can do the whole analysis again and say summation of moments at A equals 0, and then you have, I'm gonna do it. It's the first one. If you don't like it, put it in fast forward, and that's it. That's gonna be 1, negative 1 times 8 plus By times 8 equals 0. And then you pass this to the other side. 8 divided by 8 equals 1. By wants 1 equals 1. And if I do summation of forces in Y equals 0, you have Ay minus 1 plus By, which is 1, equals 0. Negative 1 plus 1, 0. So Ay equals 0, which is the same thing that you could do even without calculating anything. If the load is on top of the support, By is taking all the load and not the other support. So when x equals 4 meters, Ay will be 0 and By will be 1. Let's keep moving. Take the load, put it here. And notice that I can do intermediate steps, but I know those are going to be linear. So I don't go every single time. This one here, I didn't even have to do it. I just did it to demonstrate you, but later on you're gonna get more practice for that. So this will be number 4, 3, number 4 here, and for number 4 the load is gonna be applied there. So we do the same thing, summation of moments at A equals 0, and then you have 1, negative 1 times 12 plus By times 8 equals 0. And when you solve this part here, then you get what? What you get? You get By equals 12 divided by 8, and 12 divided by 8 is 12 divided by 8 is 1.5. 1.5. When it's 12, I'm gonna put it here before I forget. 1.5, 1.5, and then you do summation of forces in Y in X, please. Could you have any influence line in X? Well, you could, because if the load is inclined, the X will be changing also direction. So yes, you could have, but in this case, of course, it's vertical load. So you have what? AY minus 1 plus BY, but BY is this, equals 0. So negative 1 plus 1.5 is positive 0.5, pass it to the other side, and AY will be negative 0.5. Those are the two values. And then you're going to have here negative 0.5. Now what is the next step? Plot your influence lines. Do a plot of your influence line. This is for A, and this is for B. Remember, in this axis, it's going to be X. This is going to be influence line for the reaction at A when a moving load is applied, a unit moving load is applied to that structure. And this is going to be BY here, also same thing. The reaction at BY will be like that. Okay, so we can say this is 1. And let's start. For X equals 0. Ay, my back is killing me. For X equals 0, then you have what? 1. 0, 1. And then the other one is what? 4. Let me put the 4 here, the 8 here, and the 12 here, and then let me do the same thing for these two. So this is going to be 4 meters, 8 and 12, and this is in meters, and meters, and this is 4, 8, 12. So this is 0, 1, 0, 1, perfect. Then you have 4, 0.5, so let's say 4, 0.5. Then you have 8, 0, it's going to cross 0 here. And then 12 is going to be negative 0.5, meaning if this is 1, this is going to be kind of somewhere here, negative 0.5. Negative 0.5, 12, there, negative 0.5. And now you get a ruler. If this is a scale, that should be, remember, these should be straight lines. And of course, this is going to be a complete straight line, same slope, because I'm not changing anything. So this is here, once again, this is going to be 0.5, this is going to be 0, negative 0.5. And that will be the unit influence line for AY. Now for BY, which is this one, I'm going to start in 0. Then at this point, which is 4, is going to be 0.5. So let's put the 1 here. 1 is here. 0.5. 0.5. Right there. 0.5, and let's put the 1 here. 0.5. And then, what am I? Here. And 8 is 1. 1. Right there. And at 12 is 1.5. So 1.5 is going to be somewhere here, and 12 is going to be somewhere here, 1.5. And now you do the same thing. You take a ruler, because everything is not changing. That should be a straight line completely. And this is not correct. I just finish it because I don't know, my OCD. And this will be it. Now this is really interesting, if you see, because this is this is repeating perfectly the experiment that I was doing the other day in the introduction lecture with a different type of beam. And look at this. If you start interpreting this, when the load is at the location 1, the support AY will absorb the totality of the load, and the support BY 0 of the load. When the load is at the center, both of them are gonna get half and half, and that makes sense, right? Forget about this part because it doesn't have any weight over there. If the load is at the center, half and half. Now when the load is on top of B, B absorbs everything, and A doesn't. B absorbs everything here, and A doesn't absorb anything. And when you pass, now look what happened when you pass. When you pass this thing. When you pass this thing, if I push this down, this is gonna try to go up in that direction, so the reaction has to hold it down, you know. Imagine this is the beam. This is what I'm trying to tell you. If I pass and I put the load here, every single other point, this reaction was up because it was trying to hold that load. Now when I pass this point and apply the load here, if I apply the load, this is going to try to do that. And if this is going to try to do that, means that the reaction has to come down, inverted. And this is why we get this negative 0.5 value at this point. And the reaction in B is greatly increased because it's not only now taking this one, but it's taking this other part of this other reaction. That's the other 0.5, and that's why you get 1.5. At any point in this beam, you should have, if you do summation of forces in Y, you should get 1. Look at that, 1 plus 0 is 1, 0.5, 0.5 is 1, this is 1, and 1.5 minus 0.5 is 1. So this is the first approach, brute force. Now, in the second part, I'm going to do the same problem, but instead of doing every single calculation once and again and again and again, then we're going to use an equation to do that. Don't go anywhere. Look at the next video. Have a nice day.